Good afternoon, dear students. We can start our lesson. Today we have two pairs, and we will go more further in detail how to the model the advanced parts. For example, the called the surface modeling, and here you can see the surface tab is active in my cases. So for example, so far we have seen the sketch tab. So we started the model by creating the 2D sketch here, and we go last week the future tab, so the solid elements. Now here you see here the third tab in my cases is the surface tab, so it's active. So if you cannot see the surface tab in your the Solidworks, you can just activate. For example, if you have the sketch tab, you can go to the sketch tab and right click, and here you see the tabs, and here you see in my case the surface tab is active, the sketch tab and the future tab, and there's so many tabs here. So now we will go with the surface, so you can activate here by clicking the. So if I clicked here the surface, so from my tab, so the surface tab is disappeared. So you can add by yourself the right click, the tab and the surface. So the surface tab is added here, and if you look first for the surface tab, you can see here that there are several the functions here. They are almost similar for what we have seen in the future tab, but the big difference that you will create the surface element, not the solid element here. For example, that we will see the step by step all of them. So for example, that if you look here as a first function here in the surface tab is extruded surface. So what we have seen here in the future, so extruded boss, it's almost similar, but you will create in the surface extruded surface, the surface element, and so on. And you can see here the revolved surface, that is the swept surface and lofted surface, and so on, what we have seen the same in the future tab and so on. But in the future tab we have seen the functions. In the surface tab there are more or less, but there are the other functions. For example, what is the useful, that is the trim surface, very useful tool. And here you can see the night surface in order to combine. And here we have the second function, that is in order to convert the surface elements to the plastic element to give some thickness. So we will see all of them how to use today, and in the practice you will do. I will share in the Telegram group, so how to model, for example, this kind of elements. So you see here the complex elements. So this kind of elements that can be only obtained by the surface functions. So and also here you can see the other examples. It is created by the surface functions. So the surface element, that is a plastic element, and here you can see here this kind of the bottle. So if you here go to the section view, so you see this is a plastic element. So the inner side is a hollow. So so it's complex, and as an example here can create this kind of the complex elements as a mouse here. So using the surface elements, if you go to the section view, you see this inner part is the hollow, so as a plastic element. So there is no any solid element, so this is call it as a surface elements and so on. And as a last example here, just as a cup here, you can see here using the surface elements, so you can create this kind of the parts. So as a real example, I will just open here this one, and you can see here the using the surface elements you can create this kind of the complex elements, that's the bottles, the cans, and so on. For example, you can create this kind of elements by yourself. So there's most of time that will create this kind of complex shape and so on using the surface, the tab. So let me first of all the distinguish that the go with the functions here, distinguish between the surface elements, the solid elements, and the plastic elements, and so on. So let me just open the file for the solid element that we have did in the practice. For example, this one. Let me open this one, and this is the what we call it as a solid element, which we most of time that created this element last week using the feature tab here, the extruding, extruded cut, and so on. So it is easy that, and why it is called as a the solid element. So if I go to the section view, so you can see here this is the material. I can drag this arrow to see this part, which is the full of the material. So if we assign the material for this element, for example, here by the assigning the material. So for example, let's assign here the any material, for example this one. Just click apply. So and this material will be applied to this solid element, and all of the inside will be this material which we assigned here. So this is the solid element. So I can close this one. So then, and here the example of the plastic element. So why I'm calling this a plastic element, here you can see there is the thin wall which is given by the second element here. Here you can see in the feature tab the second. So firstly that I created here the surface element, and then converted to the plastic element using the second function. So that's a plastic element. So with the thickness. So I can show here another example for the plastic element. For example, let me go another folder here. Just a moment. I think that it was here. So let me, for example, open this one, and you can see here this is an example of the plastic element with several features for the plastic. Here you see which we call it as a rib. So for the supporting these features, so this rib is used. So we learn how to model the rib here. So this is the example of the plastic element with some thickness. And if I open, for example, this one. This one is the surface element, but if you open here the section view, so you see here the thickness. There is no any thickness for this element here, so it's a thin wall. So this is the surface element, but you can convert this to the plastic element as far as that is the plastic component. So in order to convert this to the plastic element, so we use here in the surface tab here this is the second function. So we will see. So this is the big difference between the plastic elements and the solid elements and the surface elements. So let me just close all of them, all the files, and go with the analysis of the functions in the surface. So I will close this one also, and this one. So let's open the new file. So we are still the modeling environment, so that's why I will click here the part. And next week we will go to analyze the assembly, so we will try to make the assembly, so from the next week. So now we are still in the modeling, so I will select here the part, just click OK as usual. So here my surface tab is active, and let's start to see here how to use the functions in the surface tab, starting from the extruded surface. So it is similar what we have seen in extruded boss, but we will create here the thin walled surface element. So as usual, you need to start with creating the two-dimensional sketch as usual, even if when you create the surface element. So we will, as usual, select any plane. For example, let's select here the top plane and click here the sketch. So it will be becomes normal to the top plane. And here you see, as soon as I select here the sketch, my sketch tab will be automatically by default will be selected, and this is what we have seen in the sketch tab. So you can create any sketch, even if the closed profile or the open profile sketch. For example, I will select here the rectangle from the center and create the rectangle, and this is the closed profile, because you see it is the closed, and you can define here the dimensions if you want. For example, let's define here that this dimension is a 150 millimeter, and let's define this dimension as a 100. So this is my sketch, two-dimensional sketch, and now I want to convert this sketch to the surface element using the extruded surface. So I will go to the surface tab, I will select the surface tab and select here the extruded surface function. And as far as I will select here the surface extruded, so it will be automatically the extruded, which is by default the normal to the sketched plane. So this is my sketched plane, and it will be the extruded normal. And if you look here in the left side, so it is very similar what we have seen in the extruded boss, very similar. You can start from the sketched plane, or see, it is by default it is by the sketched plane, and you see here it is starting by the sketched plane, and you can define here that distance, and by default it is 10 millimeter. You can increase this value, you see this is the increasing, and here you can open here that there is the similar options, that's the blend options, up to the surface, up to the vertex, the mid plane, and so on, what we have seen in the solid elements. So let's here select here the blend option and select here as a sketch plane, and define here the distance is 50 millimeter, and I will click OK to see my result. And if you see here, this is not the solid element, but it is the surface element. You see it is the open in the up and down plane. So this is the surface element, and you see here in the left side in the part navigator that is created the surface, the extruded surface. So this is the difference between the solid and surface element. So I can go again to edit this surface element. The same way I will go to the edit feature, and you can, for example, change here the starting position. So you can, the same way you can create here the starting position by the offset. If you select the offset value, this menu here will be the open, and you need to specify here the distance where you want to start the extrude option. By default it is the 0. For example, if I type in here the 10 millimeter, it will be shifted to the 10 millimeter upward. So it will start to extrude the surface element after passing the 10 millimeter from the sketched sketched plane. So sketched plane here in the top plane. So after the 10 millimeters, it will start to create your the feature. It's the surface feature. So this is the offset. You can use here the vertex option. In the vertex option, unfortunately I cannot show here because we don't have any reference vertex. So vertex, it means at the point, so we don't have. So but if you have the any model here, you can show as a point, as a reference that will start to, here you need to specify the point. Next option is the surface. The same way here, that you need to specify the any surface where you want to start your the extrude, but in this case we don't have, so we will just skip here. And here in the direction, here in the direction one, here you see it is in upward, so this arrow represents upward direction. Here you can change here the direction by the reversing. Here it will be the downward direction if I click here the reverse direction, and if I click here this one, it will be again upward direction. So by default, so here the blend option, so we know that as a blend option that we will just specify the any value here. In this case it's 50, but you can here the different option. For example, there's a mid plane. If I select here the mid plane, so our the extrude will be the symmetrically the upward and downward, so in the mid plane. And here as a 50 millimeter represents is the total height of the extruded surface. So the 25 in upward direction and 25 in the downward direction. So in total is the 50. If I change here to the 100, and it will becomes the 50 to the upward direction and 50 in the downward direction. So it is in the symmetric. So the same way we can define here the end position up to the vertex, the surface, or you can even if go to the offset from the surface and so on. Let's go here blend option, and here we can add some the draft. So we have seen the draft for the creating the plastic elements, or you can directly create here the draft. Here if I activate here the draft, so here that you can specify the draft angle. So here is the 1 degree. If I increase here the value, for example here to the 10, and you see that my extrude becomes to be the drafted to the 10 degrees even after the extruding. So this is the draft, and here you can change here the draft direction. So by the activating here the draft outward, so it will be the drafted to the outward direction. You can specify here the any value for the draft angle, either the inward or the outward. So let me just deactivate here the draft. So that's the initial condition. And here the next one is which is the cap. So if I activate here the cap option, so you see that the upper part will be the closed. Here you see the surface is started created here in the upper part. So I activate here this one. If I deactivate this one, so let's see here the result by the deactivating this cap. So I will click here the OK. So this is the result without activating the cap, and so this is the open here and open in the bottom. But if I go here the edit feature and activate here the cap and click here the OK, and you see here this is the closet in the top surface, but bottom is still open. Here you can see here the bottom is open, and if you select here the section view, so it is still the surface elements, it's open in the inside. So this is the still surface element, just I close it top surface by activating the cap. So I will go to the edit feature again, and let's deactivate here the cap. It will be open it again, and here you can see that there's a second direction. So now we just have seen here only the direction one, which is here this one in upward, you can activate here the second direction. If you activate the second direction, so you see the from the sketched plane, it will be the created additional surface element in a downward direction. Here you see the arrow here. So and here if as soon as that you will activate here the second direction, the new functions will be opened, what we have seen so far, which is the direction 2. You can define as a plane up to the surface, the up to the surface, up to the vertex, and so on. So the plane, that means that with some specific the value of the distance, and you can create here as a draft. For example, I will create here the draft. So you see only the draft is added to the lower part, which is the direction 2, because I'm just activated here this one. If I activate here the draft to the direction 1 and increase here the value, so the draft will be added to this value. So you can create here the draft in the both sides, the same value or different value, and so on. So you see here it is the drafted in the both sides. So I will disactivate here this value and this value, so the straight extruded. And here if you look here the cap in the direction 2, if I activate here the cap, so this lower part will be closed again in this case, because in the second direction, but the upper part is still open because I didn't here activated the cap one. So if I activate here this one, so upper part, upper surface also will be closed. Now both surfaces is closed, so the upper and the lower part. If I click here the OK, so you see the upper part is closed and lower part is closed because I activated the cap option. And if I see here as a section view, this will be converted to the solid element, not the surface element, because I closed the both sides now. So it is another method to create the solid element directly from the surface element, but I don't advise to use this one, because if you want to create the similar solid element, it is better to use just the feature tab using the extruded boss and so on. Just it is the how to use this one. So I will go to the surface extrude and go to the edit feature, and I will here deactivate the cap option. So because I want the surface element, so in both directions, so click OK, and you see here it is again converted to the surface, that is the open element. So this is how to create the surface elements using the extruded surface. Now let me just delete this one, and let me just delete this one again, and let's create here another sketch. In this case the open profile. So let's create here on the front plane, click here the sketch. So let's create here the arc by 3 points. Select here the 3 points arc and create here any arc. So dimension is not important, so for in this case, so here I created this arc. It is call it the open profile, because you see it is not closed so it is the open profile. And you can go to the surface again here, select here the extruded surface, and if you select here the extruded surface, so it will start to the extruded linearly. So obviously it is will be the normal, it will start to the extrude normal to the sketched plane of your this sketch, so normal. And here the same menu, you can go for example as a mid plane, and here increase the value and click OK. So you see here I created the just surface element using the open profile. So you can create another surface element. Just click here the extrude and select here this surface and click here the spline and specify here the as a direction. Here as a direction, let's create here, select as a direction is the top plane. So if I select here as a direction as a top plane, it will be the extruded this surface. You see the shape. So here the as a direction, I select here the this top plane and I click here OK. So I can create this kind of surface element. So it is the open. So you see here it is open, only the closed in the lower part here, because I as an initial surface I extruded this lower surface. So upper part is closed, I mean open. You can go to the edit feature and click here the escape. Here you see the upper part will be the closed and click here the OK. And if you go to the section, so this is the still surface element, even if I close this upper part, because I didn't close here the lower part here, because here if I go to the edit feature and go to the as a second direction, here you see it will be the second direction. If I click here the as a second direction, I will close here the second direction by activating the cap here. So lower part will be the closed. Click OK here, and if I go to the as a section view, now again the same, the solid element is the create, because I closed the both sides from the upper part and the lower part. So this is the how to use the extrude surface. And now let's see here the how to use the revolved surface element. So let's open the new file here. Let me just close this one. So as usual, in order to create a revolved surface, first of all you need to create the sketch, the profile, open profile or the closed profile, and you need to create the revolve axis of the revolving. So you need to create the axis for the revolve. So firstly let's create here the sketch. For example, let's create here the sketch on the front plane. Create sketch here, and using the line, for example, let me create this kind of profile. So the closed profile, I will select here sketch, and I need to create here the additional axis. So the reference axis, so here center line, in order to revolve this profile. So select here the center line, and from the origin let's create here the vertical axis. So I want to revolve this closed element here, this one, around this center axis in order to create the revolved surface element. So I will go to the surface tab and select here the revolved surface. So as soon as I will select here the revolved surface, the system, the Solidworks that recognize, then automatically that revolves the closed surface profile around this center axis. So here you can see here the line 7 in my cases. So this is the center axis, and it is the revolved around this center axis in the by degree of the 300 degrees. So you can specify this value. If you select here the OK, and this is the result, and this is the not solid element. Yes, this is the not the solid element. So if you select here as a section view, you see here that this is the scene wall, the surface element. Here you see there is no any thickness for this material, and I will click here OK.
How will you give a thickness to this?
So here we will step by step learn how to give the thickness. OK, just now we are creating just the basic shapes, so then we will convert these shapes to the giving the some thickness, so we will convert to the plastic element. So we will see the step by step. Just this is the basics now. So here you see it is the open the here there is no any material the inside, so it's a thin wall. I will click here that the section wall. So I will go to the as a edit feature, and here you can see you can change here the axis of the revolvers. So here you see by default this one is selected, so you see it is the rotating around this axis, but here I can change here this one. I will delete this one, and I can select here as a revolved axis, for example this line. If I select here this one, so it is not rotating, so just so if I select here I think that we need to change here this. So let's rotate around this one again, line 7. But what I want to show here, you see there's a blend option. It is means that you need to specify the value. In this case, since it is the revolved, so you need to specify here the angle. So by default it's a 360 degrees, so the full rotation. But for example, if you specify for example 180 millimeter, so it will be the revolved to the half, so to the 180 degrees. So starting from the sketch profile, always takes into account to the counterclockwise direction. So if let me just show from the top view. So this is my sketch plane. Here you see my sketch profile, and it will start as a 0 this point and rotates to the 180 degrees here this angle. So if I specify here for example the 90 degree, so it will be rotated to the 90 degree. So it is starting from the 0. If I specify here the 170 degree, so it will be rotated to the 180 degrees, and so on. You can specify here the rotation angle, or you can specify here as a mid plane. So mid plane, you see it will be rotated as a mid plane. For example, if I specify here the 90 degree, so 90 degree will be in total, but from the starting in the sketch plane, that is the 45 degree to this side, and 45 degree for this side will be the rotated. The same way you can specify here up to the vertex if you create more the complex shape up to the surface, and offset from the surface, and so on. And here we can activate as a second direction. So if I select the second direction, so here this one will be activated here, open it, and you can specify the two different values for the rotation. For example, you can specify as the first rotation as a 45 degree, for the second as a 90 degree. So this is the blue is my sketch plane, and starting as the first direction is the 45 to this direction, and the second direction is here to in the right side is the 90 degrees. So here you see as the blend option. So this is how to create revolved surface elements. So you can create different revolved surface elements. For example, let me just delete this one. Let me delete the sketch, and let's create here select here the front plane. So I will create here for example the arc here, and let's create here the line, another line, for example 2 line, and let's go to the surface and select here again the revolved surface. And but you see here it is not revolving, the feature is not creating, because we have the two center the center line for the revolving. So we need to specify here in which center line I am going to revolve, for this one or this one. If I select this one, it will be the revolved this main line, which is the bold blue, will be rotated around this one. You see here the rotated around this one to the degree of the 360 degrees. So this is the result here. And if I go to the edit feature and delete here the line 2, and as a rotation axis, if I select here this axis, so it will be the revolved around this one, so the different element here. If I select here this one, you see it is the rotated around this one. So it depends on you to specify which axis that you want to rotate your sketch. So you can rotate by yourself. So this was how to create revolve surface elements. So now we will go further. Here the swept surface. So last week we have seen in the future, in the advanced feature element in the surface, in the solid elements, we have seen the swept boss. So also in the surface there is the sweep surface function exists. It is totally similar. The working principles, the logic of behind how to use this surface sweep is similar what we have seen here in the sweep boss, but the difference is that what we have seen in the sweep surface, we will create the surface elements. In the future, that we will create the solid element with the material inside. So let's use here the swept surface. Let me open again the new file here. So I can close the previous file. I don't need. So as usual here you see it is not active, but in order to activate this web surface, we need to create first of all the sketch. We need to create firstly the guide curve. If you remember, in order to use the sweep function, we need to create as a guide curve. So let's create here the one guide curve. For example, using the front plane, I will create here the one guide curve. For example, let me create here using the line, starting from the origin, the vertical line, and go horizontal line. I will exit. Our guide curve here, you see, should be the tangent on this intersection point. So in order to create here the tangent, I will use here the fillet between this, so we can increase here the radius, for example this value. So now this is my guide curve for the swept surface function. I will exit from my sketch here once more again. So I exited. So I created my guide curve. We can define the dimensions, so I am not specifying here the dimensions, here the radius and the distance and so on. But with the real examples, you need to specify here the dimensions. So now let's convert this guide curve to the surface elements using the swept surface. Here you see now it is active. It means that we can use swept surface for this sketch. So I will select here the swept surface, and if you look here to the swept surface menu, that is the very similar what we have seen in the swept boss function. That's you need to select here the sketch profile. You can create the element using the circular profile, and so on. Yeah. So as an initial, let's use here the circular profile. So I activate here, select the circular profile, and I need to specify here which is you see here the symbol is the guide curve, and I will select this line as my the guide curve. As soon as I will select my guide curve, the tube is started created. This tube is started created, and here you can see here the diameter of this tube. By default is the 10 millimeter. I can increase this value according to my requirements, according to my sketch dimension. For example, the 30 millimeters. So you see it is increased. So this is circular profile, cross section. If I click here OK, so you see the tube is created, but if I zoom here, there is no any thickness for this one. So because it is the surface swept, it is a thin wall, and if I click here the section, and you can see here this is the created. So this is the swept surface, and if I go to the edit, and this is the swept surface using the circular profile. So with the diameter of the 30 millimeter in this case here. But you can create here the complex shapes using the sketch profile. But in this case, you need to create the additional profile by yourself, not the circular one, but different shape. You can create the slot, you can create a rectangle, you can create a triangle, any cross section of your profile, even if circular one. So let's see here this option. But in a sketch profile, you need to specify here the profile. But in my cases, I don't have the profile. So firstly, you need to create your own profile. So let's close this one. Let's delete this one. Now let's create our own profile. Firstly, we need to create the additional reference plane. So in the future tab, we learn how to create the reference plane here using the reference geometry. If I open here the reference geometry, here you can see the plane. We have seen several options how to create the reference planes, additional reference planes. The same way in the surface tab, if you go to the surface tab, also that we have the reference geometry. If you open the reference geometry, that is the function that we have here. You can create the plane using this reference geometry from the surface tab, or using the reference geometry from the future tab. It is the same. You can use any of them. I will use here the surface, so I will go to the reference geometry and select here the plane. And I want to create here the reference plane on this point, so that's why I will select here this line, and I will select as a second reference this point. So new plane, you see becomes the blue, so will be created, which is the normal to this plane. So I can accept this plane, and I will click here OK. So the new plane is created this point, which is the normal to this line and passing through this point. And I want to create the profile for this new plane one. So in order to do this, as usual, I will select the plane. This pop-up will be created, so open it. I will select here the sketch, so it will become the normal. And I can create any profile, for example the rectangle from the center. So I want to create here this one. So here so this is the profile, and I can, for example, convert the edge of this profile to the fillets. So for example, this point, so here we need to decrease here the radius, so it's too big for this sketch, so the 10 millimeter. So this edge, and this edge, I will exit from this profile. So now I have the two sketch. This is my guide curve, and this is my profile, and I want to create the surface element using the sweep function. So I will go to the sweep surface. I will select here the options of the sketch profile, and I will select here the profile, this the sketch here, you see it's selected, and as a guide curve I will select this one, so it will be the swept this profile along this guide curve. So to see the result here, I will click here the OK, and you see I created the profile passing through this one. If I go to the section and see here, there's a section view, it is the hollow element, that's thin wall element. So it is how to use here the swept surface. So when you are using the swept surface, what you need to keep in mind. So let me just firstly create one line here to the top plane. Select here the top plane. Let's create here this line. So let's create here another guide curve to the front plane. So let me just create here the guide curve. So 3-point R here. So you see, I am creating the guide curve, which is the same plane of the profile. This is the profile, which is here the circular profile. I am creating the guide curve, which is the same plane. So when you are using the surface, you mean the surface sweep, your guide curve should be in the same plane in order to properly work your function. So the sweep surface. So that's why I am starting from this one. So if I click here the exit and go to the sweep surface and select here there's a profile this one, and select here this one, so it is the swept along this guide curve, so circular profile. So let's see here another example. For example, if I have here let me create here the one datum plane, so the reference plane, and in the distance, for example, from the top plane. So let's increase here the value. So click OK, and let's create here another plane, the same parallel plane with respect to the top plane, but in a downward direction, here the flip offset. So I am creating two reference plane, which is this one and which is this one. I can change here the normal direction here. So I created two datum planes here, this one and this one. So now I want to create here for this datum plane new profile. For example, let's use here again the circular profile. Finish. So for this datum plane, let's create another profile. For example, here the circular one. So I can rotate here. I have the two profiles, this one and this one, and we have this guide curve. So using this guide curve here is the sketch 15 in my case. I want to create the swept surface for this profile, for this circle, and for this circle. So let's see here the result. So swept surface, as a profile I will select for this one, the upper one, and as a guide curve I want to use here this guide curve, which is the sketch 15. You see it is the highlighted in the orange. So you see it is the swept, but it is not the proper swept. But even if it is the working, even if it is the working, now let's use here the swept for this one as a guide curve. Let's use again the same sketch 15. So you see here the sketch 15 as a guide curve is selected, but if I select here the OK, it will give the error. It is not sweeping, because if I look from this side, I am going to sweep this profile, which is on this plane, along this guide curve. But you see here that this guide curve is not crossing with this profile. That's why it is not sweeping. It is giving the error. But I am as a first option here. You see I swept this one, even if it is not proper solution, result, but it is the sweeping, because here you see that this guide curve is crossing along this profile. So this is the logic to work with the sweep function. So your guide curve should be passing through the profile if you want to create the sweep surface function. So if it's not in the same plane, it will be not created. So let me open here another file here. So let me create here just single line on this plane, top plane, any vertical line, the horizontal line. So let's create here the one line here again. So I have the two lines, this line, horizontal line, and vertical line. Let's select here the swept surface again. Sketch profile option. As a profile, I select here this line. As a guide curve, I will select this one. So it is just straight extruded single line. But here in the option, if you go to the option, you can here go to the twisted option, the twist value, and here you can go to for example the revolution, and increase here this revolution. If I increase here the revolution to 1 degree here, you see it is the twisted. So this is a very useful tool to create the threads and so on. So it is the twisted. You can change here by the degree. So you can buy the radians and so on. So the same result, but with the different options. So this is just twisted option with the swept surface. So what is some limitations? This limitation with the swept surface is that you need only to create your elements with a single profile, with a single guide curve. So we have some limitation. We just only to create some tube elements and so on. But if you want to create the complex elements, like the bottles, in order to control the shapes and the cross sections or the profiles. We have the another functions here, which is the lofted surface. So lofted boss, we have seen here in the future. We have seen here the lofted boss. So to create the solid elements in the surface, also the similar here, the lofted surface. So let's see here the how to use this one. So let me open here the new file. So I will click OK. So I can close the previous file, so we don't need. So in order to use here the lofted surface, we need to create firstly the profiles, at least 2 profiles. So you need to create at least 2 profiles. So first profile I will create here on the top plane, the select sketch here. So let's create the profile, the circular profile. Finish, and create a second profile. We need to create the first plane, the reference plane at a distance. In this case, with respect to the top plane, let's increase here the value. For example, the any value for the 150 millimeter. So let's create the second profile, the section to this plane. Select here this one, sketch. So let's create again circular profile. We will see the complex. So I have the 2 profiles, both of them are circular, and I want to create the surface element by combining these 2 profiles. So it is the simple. Is using the lofted surface. Click here the lofted surface, and here as a profiles, the box, you need to specify your the profile. So I will select here the first profile. You see the sketch 1 is selected, and I will select the second profile. So the second profile is selected. Just it will directly combines 2 profiles, normal combines. If I click here the OK, so this is my result. Just simple surface element, thin wall, and the inside is the open hole element. This is the simple to use the lofted surface. And here you can control the start and end positions. If you open here the start and end position, for example, let's go with the control of the start. So the lower part is the start, because we let me just clarify. So this is the start position, because we selected as the first profile the lower circle, and I want to control the shape of this one. In order to do this, I will go to the start and go to for example, the normal to the vector, normal to the profile. So you see the shape will be slightly changed to the degree, and you can control here the shape. So click OK here. So it will be the little bit the shape will be the controller, the outer shape. If you want to control the end, go to the edit here, and here end constraint. So go to the normal. So here you can see here this arrow can control this shape. Click OK. So you see the quite different shape is obtained by the controlling the end and the start limits using the lofted one. In the lofted surface, you can create the elements using the profiles. In this case, I just used the 2 profiles. Just use 2 profiles. Let's create another surface element using the 3 profiles. I will delete this one. And firstly, I need to create a new plane again, one new plane, for example, with respect to this plane. And I will select this plane, select the sketch, and let's create here another profile. For example, the different profile like ellipse. So let me create a smaller ellipse. So you can control the shape here, XD. So now I have the three profiles. So circular one and ellipse, and I want to create the surface element by combining these three profiles. So lofted surface, select here the first profile, keeping here in the profile, select as a second profile, and it will be combined, and as a third profile, so it will be combined by the three profiles. I will click OK. So this kind of shape is obtained using the surface boss, and go to the edit feature. Again, we can control here the start and end limit, but in this case the start limit is a sketch one, which is this one. We can control this one, and the end one is this one. In this case, and becomes here the ellipse, not here the middle one. So now we can control the as end. This one is the ellipse here, as a start one is this one. So let's hear the result, how we can control here the shape. So as a start, again I will increase here the value, and we can go here as end. In this case, here what we have seen here, this one is the ellipse. So this is the result that slightly changed. So you can use any profile, rectangular profile, any profile, and so on, according to the sketch. So we can decrease here the value, but also we can create the more advanced and more complex shapes using the lofted surface. How? Let's see here the how. So in order to do this, if you look to here, we have control. Let's here go to the known, again to the known initial condition. So let's close here the start and constant, but here we have the guide curves, the options to the guide curve. So this guide curve is used in order to control the surface, which is the outer shape. So if you look here, that's outer shape is just straight line, which is just combining with the straight normal to these profiles. But using the guide curves, we can create the more complex shapes and control here the outer shape as the requirements and the shapes and so on. In order to do this, we need to create obviously the guide curves for the other planes. We can create one guide curve, two guide curves, 3 and 4 as a maximum. So let me firstly just delete this surface element, keeping these three profiles. Let's firstly create the guide curve. For example, on this plane, for example the front plane, select here the sketch, and let's create here the guide curve using the spline line. Most of time that we will use as a guide curve, use the spline line to create the more complex shape. For example, you can start to create the shape of the outer shape. I want to, for example, this kind of shape. In order to exit, I will right click, select here. So this is my guide curve. But what is the important to use properly the guide curve? So this guide curve should be connected with these profiles, which is these three profiles with the Pierce relations. So now let's create here the Pierce relation. In order to do this, I will just select here this point, the starting point of my guide curve, and pressing the Control keyboard, I will select the first profile, and here you see the pierce, make the pierce is appeared here. I will select here this one. So it will be connected as a pierce relation between this guide curve and this profile. Click OK, and I want to connect this point as a pierce relation with this profile the same way. So it is connected now, and last step here this one. So click here this one, press the control keyboard, press here this one, and make here again the pierce one. So this is my guide curve. It is looks like nice. So if you want to more the different shape, you can here the handle. You see here the snap, that's the points. You can drag these points and change the points. So I want to, for example, keep this. This is just one guide curve, but I want to create another guide curve that's similar but the opposite direction. In order to do this, I will firstly create here the center line as a new reference line, starting from the origin, just the vertical line here, any vertical line. The dimension is not important. What is the important? It should be the vertical. You see here the vertical symbol, and I want to make here the mirror of this guide curve around this center line on this side. So in order to do this, we have the mirror entity. That's for the sketch, the mirror. I will select here this sketch as the mirror and go to the mirror about this line. So it is the mirrored. So you see, click OK. What is the important? Since I am the mirrored here this sketch, here the pierce relations also will be the mirrored on the disposition, on the disposition, and the disposition. So you don't need to put here the pierce relation for this mirrored element. So it is in order to not to waste the time. So I created my two guide curves. I want to create the surface element. I will select here the finish. So I have this sketch. Now I will go to the surface lofted surface, and I will select the profile as this one, second profile, and third profile. So what we have seen so far, but I want to take the shape of this profile in the outer shape, create a more complex shape. And in order to do this, I will go to the guide curve option here, the box here. You see the blue is selected. I select here and select the guide curve here. Select this one, and I will need to accept here this open with this menu open. I will select here OK. You see it is taking the shape only in the one side, and in order to take here the second shape, I will select this one and click here this icon. So it will take the more complex shape in the both sides in the symmetrically, and so I will click here OK. So now I control the surface in the both sides and created more complex shape, and it is more or less looks like to the bottle. And if you select here the section view, you see here this is my result. I will click OK. I will select here the section to go to the full preview. You can hide this additional planes here, the height, then the height, and so on. So I just control it by the two sides, but you can control the more and create the shape. For example, from this I control it from this side, but here if you look from this view, it is the straight connected, but you can create and connect these shapes here. In order to do this, we need to create additional guide curve for the not front plane, but for the right plane in this case. So in order to control the shape in this view. So let's delete this one. So, and let's create here the guide curve for the right plane, additional 2 guide curves, and let's create here the let's write here the guide curve using the just a single arc here. You can, for example, this kind of arc, and it should be again the Pierce relation between the guide curves and the profiles. Again, I will make here the Pierce relation. What is the important here? This one. Let me try here the another relation. Maybe I will take here the tangent, but it is over constrained. Control Z. I will maybe I will delete this guide curve and try to use here the different guide curve using the spline lines the better, because it will create the point. And let's create here this kind of shape and make the connection again this point with this profile, the pierce, and let's this point with this one, the pierce relation, and the last one again this point with this one is the pierce relation. So this is the shape here. Now again I will make here the mirror. Firstly I will create the center line again, starting from the origin. It should be the vertical. The length is not important. And make here the mirror. This one, the mirror about, I will rotate little bit, and it is the mirrored. Again pierce relation, also the mirrored. So this is the last guide curve. So I have the fourth guide curve. I will exit. Now I will start to create the surface element. So lofted surface. Start to select here the sections. This section, this section, and this section. And as a guide curve, I will go to the guide curve and start to select all the guide curves step by step. So I will select this one. So it's not selected. Now it's selected. Click here the OK. So you see it takes the shape. Rotate the position and select the second guide curve. This one. Take here the shape and select this one. Click here the OK. And click here the rotate and select here the proper guide curve, last one. Click OK. So now I control the body from the 4 sides. I will click here the OK to see the result. So this is the element here. So now here you see lower part is open here. But we can close this lower part like the bottle element. In order to do this, we have here the 2 functions, which is the planar surface or the fillet surface. We can use here the both of them to close this lower part. So let's use here, for example, the planar surface, and just click here this edge. You see the circular edge. If I select here the circular edge, here you see it is the closed. So it is the closed and becomes the surface element. I will click here OK. So you see the lower part is closed, and here you see the planar surface is created here after this surface loft. I will delete this one to see here the second option to close the bottom part of the bottle. Here using the fillet surface. I will select the fillet surface and just click here the lower part. So it will be the closed again with the same result. So different function with the same result. So it is the closed. Let's go to the section. and you can see here we create here the surface element. So but here you see this is the thin wall. There is no any thickness. So now let's see to convert this thin wall the surface element to the plastic element, like the plastic bottle. So we need to create a bottle element. Here we have the second function. In order to do this, in order to make here the second, firstly let's use here the what is the night surface here. The night surface is used in order to combine the surface elements. So here you see we have the two different surface elements. This is this one, which is we created by the surface loft, and here this another surface element. It's a surface field. They are different. They are not combined. In order to combine and make the unite element, we use here the night surface. So select here the night surface and just select here this surface and this surface in the bottom, and just you see here it's two surface element is selected in the menu, and just click OK. So I just combined these surface elements. After making the combining, then you can convert the element to the plastic element, give the thickness using the secant. So let's do this. So click here the secant, and here if you select here the secant, that we have the three options. We can create the secant by the both sides. It will create the symmetric thickness. For example, let's use here you can define here the dimension. Let's here the 2 millimeter, and select here the element, and if I will go here, you see the 2 millimeter and 1 millimeter in the one side and 1 millimeter in one side will be the added the material, will give the thickness, because here in the both side is active. I will click here OK to see the result. You see it will become the plastic, the secant element. You can go to the section view. Now you see here the material is added here with the thickness function. So this is the both sides thickness, and here another option is the thickness in the one side. If I select the thickness in the one side, it will be give the thickness only in the one side, 2 millimeter. If I select here the one side, here this one, the thickness will be given in the another side, which is the inner side. So you can define the method to give the thickness of the material. So you can give in the both side, in the one side, or in a different side, and so on. So most of time that will be given in the both sides in symmetrically. And let's decrease here the lightly the value to the 1 millimeter in total. So this is here we can finish for the first pair, and we can make here some breaks. Then we will continue with the more advanced functions, and here the other function in the surface element. No, we can make here some breaks, 10 minutes break, then we can continue.